It says that this is section 4, by the way, and we know that we are only required to do one, but for practicing sakes, we're doing both. It says there are 60 students in the sixth form of a certain school. Mathematics is studied by 27 of them, biology by 20 of them, and students study neither mathematics nor biology. If a student is selected at random, what is the probability that the student is studying both maths and biology only? Now, I like to do these questions with a Venn diagram. So I just like to set up my Venn diagram. Nice. My Venn diagram looking very pretty. All right. Just setting up my Venn diagram. I want it look pretty. Yes, this look pretty. No, sir, this too pretty, man. Now it says there are 60 students in the school. Only 66 formers. Mathematics is studied by 27 of them. Biology by 20 of them, and 22 students do neither biology nor maths. So outside you have 22 pitney that them decide that them not hurt up them head. Biology are too much reading, right? And they don't want to do mathematics. Now let's say this is mathematics M and this is biology B. Let's say X amount of students to both, all right? Let's just put it as X. Now, for those that the maths only will be 27 minus X, all right? And then it says biology only will be 20 minus X. So this is what we have. So let's find out what is X to know what's the intersection. Now we know that 27 minus X plus 20 minus X plus 22 is equal to 60. So what we do know then is 27 plus 20 is 47, and 47 plus 22 is 69. So 69 is equal to 69 minus X is equal to 60, and so X equal 9. So that means 9 students do both. 9 students do both math and bio. So 9 students do both math and bio. Since 9 students do both math and bio, it asks now, what's the probability that a student is doing both math and bio? So now that we find how many do bio, and that means the probability of a student doing math and biology, probability of M intersect B is equal to the total number of students that do both, which is 9, divided by the total number of students in the school, which is 60. So that's part I. Now the second part says, what is the probability a student does biology only? So the probability a student does biology only. Let's work that out. So the probability a student is doing biology only, which is just the probability of B only, meaning biology only. That's going to be, how many students do bio only? 20 minus 9 is 11. That's going to be equal to 11 over 60. That's the probability a student do bio only. Nice and easy, soft. Now it says copy and complete the sample space. That's the next part of the question. We're just going to make a border around here. For part B, I'm gonna make a border around here. This is where we're gonna do part B. And let's create the box now to represent the sample space. Nice and easy. So creating our box. In the meantime, we read the question. It is saying, two ordinary six-sided dice are thrown together. The random variable S represents the sum of their scores. Copy and complete the sample space. So this box that we're constructing is just a sample space diagram that represents the sum of the scores of the two dice. All right, so 1, 2, 3, 4, 5, 6, and we need 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. This is it. 1, 2, 3, 4, 5, 6. Yeah, this is good. Then we need 6 going down. 1, 2, 3, 4, 5, 6. All right, and just one final thing is missing. These are the dice going here. Oh gosh. Really trying my best to get these correct. Let me use a straight edge. Not doing so wonderful with this. Getting the straight edge. To get in the straight edge, we have 6, 5, 4, 3, 2, and 1. And this now is 1, 2, 3, 4, 5, and 6. Nice and easy. Now it wants us to fill out the sample space. So let's go ahead and fill out the sample space. The sample space is going to be right here, 1 plus 1. 1 plus 1 is 2. Then over here, it's going to be 2 plus 1, which is 3. 3 plus 1, 4. 4 plus 1, 5. 5 plus 1, 6. Then 6 plus 1, 7. So that's the sample space. Let's go to here now. It's going to be 2 plus 1, 3. 3 plus 1, 3. 2 plus 1, 3. 2 plus 2, 4. 2 plus 3, 5. 2 plus 4, 6. 2 plus 5, 7. 2 plus 6. 2 plus 6, 8. That's the sample space right there. Let's go over to here now. 3 plus 1, 4. 3 plus 2, 5. 3 plus 3, 6. 3 plus 4, 7. 3 plus 5, 8. 3 plus 6 is 9. So get the gist of it already. So right here now, which is just going to be 4 plus 1, 5. 5, 4 plus 2, 6. 4 plus 3, 7. 4 plus 4, 8. 4 plus 5, 9. Then here it's going to be 4 plus 6, which is 10. Nice and easy. Right here, so now is 5 plus 1, 6, 5 plus 2, 7, 5 plus 3, 8, 5 plus 4, 9, 5 plus 5, 10, 5 plus 6, 11. Then up here now it's going to be 6 plus 1, 7, 6 plus 2, 8, 6 plus 3, 9, 6 plus 4, 10, 6 plus 5, 11, 6 plus 6, which is 12. Nice. So that's completed it. Then now part 2 says, let's try and we should be able to do everything right here. Break this all the way down here. Now part 2 is asking for find the probability that s is greater than 9. So let's work that out. It's saying find the probability that the score is greater than 9. So what's that going to be? So first, we need to identify scores that are greater than 9. It's going to be 1. All of these are greater than 9. Shouldn't put the line right there. Greater than 9 will be all of these. 10, 10, 10, 11, 12, 11. So greater than 9 is 1, 2, 3, 4, 5, 6. These are greater than 9. Greater means bigger than 9. These are all of them. So it's 1, 2, 3, 4, 5, 6. That's equal to 6 out of 36. 6 out of 36 is 1 over 6. I want the probability that s is less than or equal to 4. Find the probability that the score is less than or equal to 4. The probability s is less than or equal to 4 will be equal to all of these down here. 4 is all of these. 1, 2, 3, 4, 5, 6, 7. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are all of them, you know. 1, 2, 3, 4, 5, 6, 7. 4 here. 3, that's 7. 8, 9. That's equal to 9 out of 36. And 9 out of 36 is a quarter. That's the probability that the score will be less than or equal to 4. Now part 3. Boy, they're killing us with the table this time, man. Part 3 says, let D be the difference between the scores. And it says, let D be the difference between the scores of the faces landing uppermost. The table below gives the probability of each value. Find let D be the difference between the scores of the faces landing uppermost. Okay, so the dice, so you have 2 dice in it. You want the difference between the scores. Now it says, let D be the difference between the scores. Now, complete the table. Now, if you chose 6, the difference will be, if you chose 6, then the difference will be 0, clearly. If you chose 2, 6. In order for the difference to be 1, that means you chose a 5 and a 1. So this easy, man, this easy. All right, so let's go ahead and knock this question out. So first, I just want to complete that table. They seem to be killing us with tables this time around. And so we have D And then we have the probability of D. Now when the difference is 0, the only way the difference can be 0 is if you throw like 1 and 1, or you throw 2 and 2, or you throw 3 and 3, you throw 4 and 4, you throw 5 and 5. That can only happen 1 out of 6, clearly. But I need nothing more. The next one now is for the difference to be 1. For the difference to be 1, that means you can show 1 and 2, or you can show, let me write it better. Let me show you what you can throw. The possibilities are you can throw 1 and 2, or you can throw 2 and 1, or you can throw 3 and 1, not 3 and 1, 3 and 2, or you can throw 2 and 3. Those still have a difference of 1, or you can throw 3 and 4, or you can throw 4 and 3, or you can throw 5 and 4, or you can throw 4 and 5, or you can throw 5 and 6, or you can throw 6 and 5. Nice and easy. Alright, so look how many options that were. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So the probability, that means A is equal to 10 out of 36. You can simplify it if you want. So that is A. So A is equal to 10 out of 36. Some persons might want to simplify it and say A is actually divided by 2, that's 5 over 18. If you feel the need to simplify it, go ahead and knock yourself out. Then for the difference to be 2, that is 2 over 9. For the difference to be 3 is B. For the difference to be 3 is B. Now what can you throw for the difference to be B? Now what you're going to be throwing for the difference to be 3 is if you throw a 1, then the next one needs to be a 4, or you can throw a 4 and a 1, or you can throw, say you throw 2, then the next one has to be a 5, or you can throw a 5 and a 2. If you throw a 3, then the next one has to be a 6, or you can throw a 6 and a 3. And so this is 1, 2, 3, 4, 5, 6 possibilities. And so what we're saying then is B equal, this is going to be 6 over 36. Now, of course, some people won't like to write it like that. Some people will want to write that B is equal to 6 over 36. And 6 over 36, we will want to say that is 1 over 6. Nice. Now, chances of the differences being 4 is going to be 1 over 9. And then the chances of the differences being 5 is, the only way the difference can be 5 is if you throw like 1 and 6 or 6 and 1. That's the only way. You have to throw 1 and 6 or 6 and 1. 1 and 6 and 6 and 1, that's 2 out of 36. C is equal to 2 out of 36. 2 out of 36, which we know is 1 over 80. Now it says now, the aptitude scores obtained by 51 applicants for a supervisory job are summarized in the following stem and leaf. It says find the median and the quartiles for the data given. It's 51 applicants. So since it's 51 applicants, the median occurs in the 26th position. So this is for part C. The median occurs at 26th position. So that's how we're going to find the median. We're going to look for the 26th score. All right, so let's look for the 26th score. Looking in the table, the 26th score is going to be 26 score, that looks like 71. All right, that's 71. So the 21 in the that's gonna be 71. It's equal to 71. So the person that got 71 on the aptitude test, that's the median. Next they want is the quartile. So let's find the lower quartile first. The lower quartile is going to be equal to, it's a quarter, it's 0.25 times n plus 1, which is 51 plus 1, which is 13. So we're looking for the 13th term, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. The 13th term is 56. So the lower quartile is at the 13th position, and that is equal to 56. That's the lower quartile. Next we need is the upper quartile. So the upper quartile occurs at, clearly the upper quartile will be at the 39th position. And the 39th position is going to be, let's see, 3, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39. So the 39, that's 79. That's the upper quartile. Nice and easy. That's part C. Now it says construct a box plot to illustrate the data given. There's 5 information that you need. You need the minimum, the maximum, the median, and stuff like that. So let's construct our box plot. So this is the box plot. You draw a line. You draw a line. The lowest score, of course, is 31. So this right here is the minimum, which is 31. The maximum, which is the highest, is 96. And then the box plot, this is our Q1 and this is our Q3, Q1. The lower quartile is 56. And this is 79. Now the median is closer to the 71. So the median Q2 is somewhere right here, which is 71. This is the median Q2. This is the upper quartile known as Q3. This is the lower quartile Q1. Nice and easy. Soft. Now we finally make it to the final question now. The final question is question number 8. Question number 8 says, figure 2 below, not drawn to scale, shows the motion of a car with velocity v as it moves along a straight road from point A to point B. The time taken t to travel from point A to point B is 90 seconds, and the distance from point A to point B is 1,410 meters. So it tells us that the motion of the car is traveling along a straight road from A to B. The time it takes from A to B is 90 seconds. And the distance from A to B is 1,410. It says what distance did the car travel from A to B before it started to decelerate? So first thing it wants, the distance that it was traveling. Remember, distance of a velocity time graph, distance is equal to area under the graph. Area under the graph, that's how we find distance. And so the distance, so this is part one, of course. Let's just label it, that's part one, of course. The distance is equal to, let's call the distance S. The distance is equal to length times width, because that's a rectangle. The length looks like 30 seconds, and that's multiplied by the width of 25 meters per second, 25 meter per second. So when you multiply those, you get 30 times 25, 30 times 25. And so the distance before it decelerate was 750 meters. That's part one. Part two says calculate the deceleration of the car as it goes from 25 to 10. Calculate the deceleration of the car. Now deceleration is negative acceleration. So now the deceleration, which is negative acceleration, all right, so minus A, all right, or we can even write A just to say acceleration. Acceleration is equal to V minus U over T. That's acceleration, V minus U over T. The velocity is 25. Well, the initial velocity is actually 25. So it's a V velocity, which is 10 minus 25 over the time t, and the time t is 10 seconds. So what does that work out to be? This works out to be 10 minus 25 divided by 10, which is minus 1.5. And so this is the negative acceleration. This is minus 1.5 meter per second squared. And so the statement now is that we can say, so the deceleration is 1.5 meter per second squared. 1.5 ms to the minus 2. So the deceleration is 1.5 ms to the minus 2. Nice. That's a whole of 5 marks. It says, for how long did the car maintain a speed of 10 meters per second? Oh shoot, an error was made right there. According to the graph, that's not 40, that's actually 38. This is 38, so this should be 8 seconds. My sincere apologies, it should be 8 seconds. Looking at the graph, that is 8. That is 8. Or mistake. That's not 10, it don't reach 40 yet. That is 8. So it's gonna be 10 minus 25 divided by 8. That's negative 1.85. Negative 1.875. All right, so this should be the deceleration, scrap this, is 1.875 meters per second. They're trying to be tricky. But that's not that tricky. Then they said no, for how long did the car maintain 10 meters per second? It maintained it from 38 straight up to 90 seconds. So this is part 3. Part 3 is that we're just going to work out 90 minus 38. 90 minus 38 is 52 seconds. All right, and so the car maintained a constant velocity for 52 seconds. So the car started to go extremely slow because Usain Bolt can run at 10 meters per second in a 200 meters. So the car slowed down drastically. It says from point B, the car decelerates uniformly, coming to rest at point C and covering a further distance of 30 meters. Determine the average velocity of the car over the journey from point A to point C. So the car, it decelerates uniformly to cover another 30 meters. So if you cover another 30 meters, remember, so first and foremost, we know that the acceleration is going to be v minus u. V in this case is going to be 0. But we don't know the time, so that's a good one. This is a very good one. It just tells us that it covers 30 more meters. So what is that telling us? So it's telling us that the car is right here, and then it's going to come to rest. All right, it's going to come to rest. So it's going to form a triangle where this point, it's at point B. This is point B, and this is point C. All right, that's point B. And point B is when the time is 90 seconds. This is point C. We don't know how long that is, but from here, we know the velocity is 10. All right, and here, the velocity is 0. So now what do we know about this right here? We know that the area under the graph is 30. If the area under the graph is 30, but we know area of a triangle is a half the base, and the base is half the base, which is 90 minus, let's call this t, half the base. So the base is t minus 90. Or let's just call it t for now. Let's just call that distance t. So it's half base times a height of 10. All right. So what does that tell us? A half of 10 is 5. So 5t, and so t equals 6. So if t equals 6, that means it takes 96 seconds in total. It takes 96 seconds in total to complete the full journey. And so now we can go ahead and find the average speed. So the average velocity is equal to total distance. Let me draw some more space. Average speed is total distance divided by total time. That's the average speed. Total distance divided by total time. And the total distance is add the 30 to the 1410. And so the total distance is just equal to 1440 divided by the total time to cover this, which is 96 seconds. And so that is equal to the average speed. 1440 divided by 96, that's 15. So the average speed is 15 meters per second. So go ahead, write it down, write it down. Tell them the average speed was 15 meters per second. That was the average speed. Nice. Finally, we're at the last portion of the paper, and it says a particle P travels along a straight line. It starts from rest at P, and after 10 seconds, it comes to another point Q, and the velocity V at the time after leaving P is given as follows. It says at maximum velocity, the particle has no acceleration. It says find the time when the velocity is at its maximum. So it says it has no acceleration. So at maximum velocity, the particle has no acceleration. All right? Maximum, the particle has no acceleration. So what that means is it has no acceleration when the particle has no acceleration when dv by dt is equal to 0, dv by dt. That's acceleration. So dv by dt is equal to, looking at the first one, it is 0. Carry down the power. So 2 times 0.72, which is 1.44. So I get 1.44 t. Then bring down the 3 now to get 3 times 0.096. That's 0.288. That becomes minus 0.288. That's acceleration. 1.44 t minus 0.288. And when this is equal to 0, it has, find the time when the velocity is at its maximum. Velocity is at its maximum when acceleration is 0. So from this, solving this equation, we're solving 1.44 t minus 0.288 equals 0. Solving this, we're getting 1.44 t is equal to 0.288, and then we divide both sides by 1.44 to get t is equal to 0.288 divided by 1.44. That works out to be 0.288 divided by 1.44. That's equal to 0.2. All right, so we're getting t is 0.2. Just to check that no differentiation mistake was made. Oh shoot, differentiation mistake was made. Definitely made. This should have been carry down the power, subtract 1 from the power. Oh gosh. Subtract 1 from the power, and that's equal to 0. So now this is what we're solving. So we can factor out t. Factoring out t, we're solving 1.44 minus 0.288 t is equal to 0. So solving this, we're going to get two possibilities. We're going to get that t is equal to 0 or t is equal to solving 1.44. So t is either equal to that or t is equal to 1.44 divided by 0.288. And what is that working out to be? 1.44 divided by 0.288, that is 5. So it either t equals 0 or t equals 5. Now let's check out the other one as well. All right, let's check out the other one as well. The other formula, the acceleration is going to be dv by dt for the next one, which should be 2.4 minus 0.48 t. And if we're to solve this equals 0, what are we going to get for t? We're going to get that. Solving this, we're going to get t is equal to 2.4 divided by 0.48. That works out to be 5. So clearly t equals 5. So clearly, when t equals 5, the particle has no acceleration. Particle has no acceleration when t is equal to 5. And clearly it now have no acceleration at the start. Then it says determine the maximum velocity. Now, what I want you to know is whenever acceleration, so this is how the particle is traveling, right? So whenever it reaches its rest point, right, at this particular point, when it rests instant, when it just rests, right, it just when the acceleration is constant, the speed buck, this is at its maximum velocity when the speed buck. When the acceleration is 0, the speed buck, and this is the maximum velocity. So all we need to do is plug in t equals 5 to find the maximum velocity. So I'm going to call it V max. So the maximum velocity V max is going to be, we just need to plug in t being 5 in the formula, 0.72 times 5 squared minus 0.096 times 5 cubed. So let's need to work this out, and that gives us V max. So 0.72 times 5 squared minus 0.096 times 5 cubed, that is 6. So the maximum velocity is 6 meters per second. That's the maximum velocity. And you can check it in the other formula as well. You're going to get the same answer, 2.4 times 5 minus 0.24 times 5 squared, you're going to get 6. So the maximum velocity is 6. Then part C now, so this is part 1. This is the answer for part 1, which is 5. This is part 2. And we're at the final part of the paper now. Finish strong. You're running at 800 meters and you need to finish strong. You need to kick. All right? So 3. Find the distance moved by the particle from P to the point where the particle attains its maximum velocity. So remember, the particle starts from the point P, right? And so what are they asking? They said find the distance at the particle from P where the particle attains its maximum velocity. So the particle P is when it is at rest. That distance, you can call it S. It's going to be equal to the integral from 0 to 5, because it attains its maximum velocity when t is 5. So it's integral from 0 to 5 of 0.72 t squared minus 0.096 t cubed. This will give us the distance moved. This is all, this is all. So let's integrate this formula now. So integrate it to get add 1 to the power, divide by the power. So it's going to be 0.72 divided by 3 is 0.24 t cubed minus add 1 to the power, divide by the power. Now 0.096 divided by 4 is 0.0024. You'll get 0.024 t to the 4 over 4. Oh, we divided it by 4 already, so it's 0.024 t to the 4, and we're integrating from 0 to 5. Now we don't even need the 0. We're just going to plug in the 5. So plugging in the 5, we're going to get 0.24 times 5 cubed minus 0.024 times 5 to the 4th power. That will give us the distance it covered. So the distance it covered when we work that out is 0.24 times 5 cube minus 0.24 times 5 cube minus 0.024 times 5 raised to the 4th power, and I get 15 meters. So it covered 15 meters. So it covered 15 meters. Nice and easy. So it covered 15 meters up to where it obtained its maximum velocity. So that's it for now. So don't forget to just please subscribe to the channel, help the channel grow. It's only going to get better, the quality and everything. All the best prepping for your exam, and work hard and you'll get those ones and those lovely distinctions. Now you take care.